All right, probability and statistics. All right, we're looking at margin of error today. And margin of error is involved in all kind of statistic things that we get, because when we do a statistic, it's not going to be exactly 100% perfect. In fact, I got some statistics on here. We're going to look on the computer. This says USA Today, if the 2020 presidential election were held today, who would you vote for? And so we've got these percentages here. How do they get these? Well, they have to ask people these questions. And so they get these numbers by the people they ask. But are these accurate? Well, there's got to be some kind of error involved. And if you notice down here at the bottom, okay, it says right here, the margin of error is plus or minus 3 percentage points. There's a margin of error of 3 percentage points, which means plus or minus right here, this is the Democratic nominee. If I add 3 percentage points, that'd be 39. If I subtract 3 percentage points, that'd be 33. So there really it's between 33 and 39. And right over here, President Trump, 39. If I add 3, that'd be 42. If I subtract 3, that'd be 36. So really it's between 36 and 42. Let's look at another one here. Okay, here's one. If you heard these Democrats were going to run for president in 2020, how would you feel? And excited, makes no difference, and whatever. But if you look down here, the margin of error, right there is kind of hard to see. Margin of error is plus or minus 3.7 percentage points. Now, you may have never noticed this on statistics that you see on TV or in newspapers. Now this one right here, this is a potential 2020 presidential race. All these are about presidents. Anyway, Joe Biden, Bernie Sanders, Oprah Winfrey. Okay. Anyway, down here you see your plus or minus 3 percentage points. That's your margin of error. So every statistic we have has some margin of error. Now, how do they calculate that margin of error? We usually, well, this is the equation right here. And I've got a little shadow on this thing I'm fighting with. Anyway, this is how you calculate margin of error. It's 2 times this radical of p times 1 minus p divided by n. Now, p is your percent. So like on here, they find that 36% are going to vote for Trump, I think, or it's 39% is what it said. 39% vote for Trump. Okay. So to calculate their margin of error, they put 39 right here, 0.39. So it look like this, 0.39. And then you do 1 minus 0.39, which is 0.61. And then you divide by how many people they polled. Now, we don't know how many they polled. Let's just put 1,000 right here. Okay? That's all in the square root, and then we have 2 times it. Okay? So all I do is, it's really simple. Let's get my calculator here. Do it to the side over here. Okay. So 0.39 times 0.61 divide by 1,000. Okay. All right, now I'm going to do the square root of that. So I'm going to do the square root of that answer. Okay, and then I'm going to times it by the 2 here. All right, that comes out to be a 3.03. So that's the margin of error. So I think that's probably what they did. They probably polled 1,000 people. I put 1,000 in there, and that's what it come up to, 3%. So that's the margin of error. And that's how you calculate it with this formula right here. Okay. Now, basically what this means, this right here is your standard deviation. When you have a percentage of something times the percentage of it not happening, and then divide by how many people you'll poll. This is your margin. This is your standard deviation, basically. And so if you look at the curve that we've talked about before, and right here's my average. So like on this right here, Trump was 39%. That was the average, what we come out with. Okay, if I go one standard deviation over, I would be here. If I go back one standard deviation, I'd be there. So what we do is we times this by 2, which means I'm going to go over 2 standard deviations, which will put me here and will put me there. Okay, which if you add up all these percents right here, that's 95%. So what we come up with is we say we're 95% accurate. We're 95% accurate with this margin of error. So that means all these polls, this thing right here that I just showed you, I turned it off. Anyway, all these polls on here, they have this margin of error. It's not exactly 100% accurate. This is 95% accurate that we have this 3%, 3.8%. The higher your margin of error, I guess the less people you would have contacted. So the more people you contact, the lower your margin of error. So, if you want to poll everybody in the whole United States, your margin of error is going to be real small because you polled everybody. So that comes into play here. So let me put this thing back here, and let me show you how to do some of these problems on here that we've got. This first one here, in a poll of 460 people taken by a television network for a sporting event, the announcer received a 73% approval rating. What's the margin of error? Okay, so I'll just do this right here. My margin of error is going to be 2 times, in here I'm going to have P, which is my 73, so 0.73. And then I have 1 minus that, which is going to be 0.27. And it's going to be divided by how many people were polled, and it says right here 460. So this is how you set it up. And so you just punch it in the calculator. So let me put my calculator on here. Okay, get this off. Okay, so I'm going to have, I guess you could punch this all in at one time if you wanted to. 2, and then I'm going to have my radical. And then in the radical, I have 0.73 times 0.27 divided by 460. And just type it all in at once like that if you want to. 0.04. So it's 4% right there. 4%. Okay, so it's real simple to do. Down here, let's do one of these. Which situation gives the lowest margin of error? So you have to type all 4 of these in the calculator. All right, so here, I'll write this one out right here. This one right here, that's going to be 2 times the radical of 0.48. 1 minus 0.48 would be 0.52, and that's going to be divided by 5,000. Okay, that's how I would type all that one in. This is going to be 2, and then I'm going to have my radical, and I'm going to have 0.89. I'm going to have 1 minus 0.89, which is 0.11, and then it's going to be divided by 4,500. And then this one here is going to be 2. My percent is 0.92, which 1 minus that's 0.08, divided by 2,500. And then this last one's going to be 2. That's going to be 0.24, and then 1 minus that's 0.76, and then divide by 3,000. And you could just type those in all at once. So that's what we're going to do here, okay? So on this first one, 2, radical, 0.48. Can you see this all right? There's a shadow in this thing. Let's see if we move this over a little bit. Okay. And then I have times 0.52, and then divide by 5,000. Okay, so this is 0.01413. I might have some that have 1%. So now I would think this would be the lowest. Just saying because there's 5,000 people versus these others are lower, I would say that might be the lowest. Just guessing. But anyway, I might be wrong. Okay, now on this one we'll have 0.89 and then 0.11 and then divide by 4,500. And that's 0.009. Yeah, this one's lower than that one, so I was wrong. See, this one has 4,500, but see, the percent is higher. That percent gets higher, that would make it have a lower margin. On this next one, 0.92, 0.08, divide by 2,500. See, this is 0.0108. This one's lower than that one. And the last one, 2.24 times 0.76 divided by 3,000. You can put that in parentheses or just hit times either way. And that's 0.0155. There we go. So yeah, right here, this one's the lowest. So it looks like B. B's my answer there. Okay, and so that's what you're going to be doing on here. Now, let's go down here to 9. Before the fall election, a poll of 380 people was taken to find the amount of support for a measure. They found that 52% of the people polled planned to vote for the measure. Find the margin of error and indicate what the results mean. All right, so on this, I'll just write it right here. My margin of error is going to be 2. Then I'm going to have my percent, which is 52%, so 0.52. And then 1 minus that's 0.48. And I'm going to divide by 380. So that's how you set it up. Okay, so I'm just going to type on the calculators here. So I have 2. Make sure you can see this. 2, and then my radical. And we'll have 0.52 times 0.48 divided by 380. And I get this right here, 0.051257. There you go, that's what I get. Now, what does this mean? It says find the margin of error. Well, look here, all the margin of errors say 5. All right, so that's 5%. So you got this right. Now, what does this mean? Well, I told you guys that this is a 95% probability, so it looks like we're at one of these two right here. This is not right. So we're at a 95% probability that this is plus or minus. So if I take my percent, which is 52, and I add 5, that would be 57. And if I take my 52 and I subtract 5, that'd be 47. So it's got to be between 47 and 57, which looks like right here, C. That's what this means. When your margin of error, whatever it is, that means you have a 95% probability that your actual percent is going to fall between these two numbers. So that's what your answer would be on that one. Okay, now let's go to the second page and we'll do 1 or 2 on it. So look at let's look at 12. 200 people were asked if they think Fox reports fake news. 63% said yes. Find the margin of error and indicate what the results mean. All right, so let's see, my margin of error is going to be 2 times 63%, so that's 0.63. Then 1 minus that's 0.37, and then I divide by how many people were polled, which is 200. Okay, so if I punch that in, 2, and then I'm going to have all right, so it's 0.63 times 0.37 divided by 200, and I got 0.068 0.27. That's what I got. That's my margin of error. Okay. Which is, I'm just going to round this to 7. Okay, so if I move this over 2 places, 6.8%, I'm just going to say 7 to make it easy. So my margin of error, 7%. Okay, find the margin of error. There it is. Now, what does this mean? All right, it means with 95% probability, the percent, let's see here, is 63. So if I subtract 7 from 63, that'd be 56. And if I add 7, that'd be 70%. So with 95% probability, 56% to 70% think, people think that Fox reports fake news. I don't have enough room to write it there. But that's what this means. So with 95% probability, 56% to 70% of the people actually think Fox reports fake news. Okay, so that's how you do that. Now we'll do one more down here. Let's do 19. Okay, get a paper here. Let's do it right here. In a poll before the election, 76% of people said they would vote for the new library edition. The margin of error was 3%. How many people were polled? Okay, now on this, let me just write this out again. Margin of error equals 2 times P times 1 minus P divided by N. Okay, on this, we're looking for how many people were polled. We're looking for the N. Okay, so what I'm going to have to do on this, I'm going to have to divide both sides by 2 to make this 2's cancel out. So the margin of error divided by 2 equals the square root of P times 1 minus P divided by N. Okay. Now I need to square both sides to make this cancel off. So the margin of error divided by 2 squared equals P times 1 minus P divided by N. Okay. Now, since N is on the denominator here, I multiply both sides by N to make this cancel off. So N times the margin of error divided by 2 squared equals P times 1 minus P. And then one last step, divide both sides by this margin of error divided by 2 squared. And there you go. My number of people is going to be the percent times 1 minus the percent divided by the margin of error divided by 2 squared. And that's how you can find out how many people you had. Okay? All right. So going back to this problem here, we're just going to let me just do this. Here we go. We're doing 19, we said. We're going to use this equation to just come up with. Okay. All right. How many people were polled? All right, so I need to do P, which is 76. So I'm going to do, well, I can do it right here. 0.76. 1 minus P, well, it's going to be 0.24. And it's divided by the margin of error, which it says was 3%. So that's 0.03 divided by 2 squared. Okay. Now, I believe you could punch it all in like this. Now, you should practice with your calculator to make sure you're getting this punched in right. But now I'm going to do 0.76 times 0.24 divide by, and then all this at one time. I can punch that in Make sure you can see this. 0.03 divided by 2 squared. I got 810. 810 people are polled, and that's B. That's my answer. Okay, so you might need to mess around with your calculator, make sure you can punch this in. If you can't do it all at one time, you probably should punch this in and get a number for that. See, if I did that, that might be better. If I do the 0.03 divide by 2, enter, and then square it, enter, and I get this point. This moves it back 4 places, so there's 1, which means I have 3 zeros. That's what this is. And now I can do 0.76 times 0.24, oops, and then divide by 0.000225. And there you go, I got my 810 people. All right, so that's how you do that. And there's a few questions like that at the end here. How many people are polled? How many people are polled? How many people polled? How many people polled? And so you do this equation right here for that. Okay. All right, so that's how you do margin of error. If you have any questions, let me know and I'll help you all I can. I hope you have a great day.